Hello friends, today I'm going to solve LeetCode problem number 649 Dota2 CNET. So in this problem we are given a string CNET which represents two parties. One party belongs to radiant which is denoted by character R, the other party represents star which is denoted by the character D. And there could be multiple rounds where each round starts from the first character of CNET until it reaches the last character, and in each round the radiant would want to kill Dar and Dar would want to kill the radiant because they want to win the game. So we start from the first character. Let's look at this example here. So we only have two characters in this string, right? The one is R and the next one is D. So we start the first round. So in the first round what happens is we have the character R, and R belongs to radiant. It would always want to kill the Dire, which is represented by the character D. So R would kill D here. So now D is killed. So in the first round R kills D, and then in the first round itself, since D is killed, D won't be able to do anything. Okay, so in the next round what happens now is we only have R in the string, right? So since there is only one R and no Dire, so that means that R, which represents radiant, wins the game, and hence the output is radiant. Now here let's look at this case here. So now in the first round we start from the first character, which is R. So R would kill D. So R kills D. The R always performs, each of the party always performs in the best optimal manner. Okay, so R would kill this D. Okay, and then what happens is, since this D is already dead, the second D is already dead, it doesn't do anything, so we move on to the next character, which is again D. Right, now D would now be able to kill R, right? So D kills this R. Okay, so the first round is now complete. In the first round R was killed and D was killed, right? In the second round we only have D. So since we only have D, Dar wins here. Let's look at a few more examples here. Okay, so I have created an example here. So we have R, D, D, R, R, D and R. So now what happens is we start from the first. Now this radiant kills this D. It would kill this D and not this one, or not this one. Why? Because let's see, if it killed this D instead of this, the next turn is of die, right, of this character. So this would kill this one. Okay, and then this would kill this. So basically we are left with two dire. Well, that is not an optimal condition. Okay, if radiant killed this star would not be able to kill any radiant, right? So this star, only we are left is with this star. So that is why we always perform optimally. Okay, so now this radiant would kill the next star, which is this one, and then this star is already killed, so we don't do anything. And then what happens next is, now we move on to this star, and now this star is able to kill a radiant, right? So it kills the one which is next, and then since it is killed, we don't do anything here. Now we move to the next character, which is R. It is not killed yet. So now what we do is, the radiant would kill a dire. So it kills a dire next to it, and then since now this dire is already killed, we don't do anything with this, and then we have a radiant again, right? And this radiant can now kill another dire. Okay, so this would kill this dire here, and then the first round is complete. Now in the second round we are left with radiant, radiant and radiant. Okay, so this radiant will try to kill dire, but there are no dire, so it would pass on to the next one. Since all of these are killed, we do not perform any operation, we skip them, and then we have a radiant again, and then the dire is killed, so we have 3 radiants. So since we only have radiants and no dire, we would just return that radiant one. Okay, So now let's see how we could solve this problem, okay, using stack method. So what is happening here is we start from the first one, and this radiant would kill a tire, okay. So what is happening is we create a stack, and then the radiant kills. Radiant is basically, this radiant is not dead, right? It is alive, so it has a power to kill one of the tire. So we just add it to the stack. All right, and then we move to the next one. Now this is not the radiant, right? Not the value which is at the top of the stack. Since it is not the value, it is a different value, which means that the radiant would kill this, right? So the radiant would kill this, and now it has already performed its job. So we remove this out of the stack, and then we actually append it to our CNET, okay. So here I am created an array out of the CNET string. So we append it to our CNET array. Now next, our stack is now empty, and we have a D tire, right? Since it is empty, we just push D, and then we know that D already has a power to kill, right? It has not yet killed anyone. So in the next step, we now have an R, and R is not equals to D, right? R is not equals to D, which means that D has the power to kill R, okay. So D kills the R here, and then now since it has performed its job, we just pop it out, and then we add it here, okay. Now in the next case, again, now stack is empty, now we have an R here, so we push the R here, okay. And now in the next step, we found a D, which is again not equals to the top of the stack, right? Our top stack has value R, so that means R is able to kill this D, and it now has utilized its power. So now we pop it out and append it here, because like these are the values that are not killed, right? That has not been killed, so they will come in the second round, okay. And now we move to the next character, which is R, and now R, since our stack is empty, we just push it to our stack, okay. So push it to our stack. Well, this R actually already still has its power, right? It has not yet killed anyone, so it still has a power to kill a tire, okay. But what we do is we move in with now the next round, okay. So we are moving on with another R that we appended to our CNET, and then we since it is equal, we just push it here in our stack, okay. And basically these R and these R are the same. So and now we have a D, okay. So basically what is that, these two R's have not exercised their power, right? Which means now one of them can use their power to kill the tire. So one of them uses their power and kills the tire, okay. So since these R has used its power, we append it here. We still have an R here, okay, which have not been used yet. So we append it to our radiant CNET array, and then next we move on with the next R, and then we push it here, okay. And then again we move on to the next R, and since it's equal to the top, we just push it here. Now our stack only has the radiance, right? And we have also reached the end of the CNET array, and the stack only has radiant now, so the winner would be the radiant. So we would just check if the first element is an R, then the radiant would be the winner, because stack will only contain either R or either D, because every time we find a difference, we just like pop it out, right? So that is why it would either be only R or only D. So that is how we are performing this operation. So now let's try to code it. So what we need is we need to create a array out of CNET, and then we need a stack where we are going to push and pop out of the stack, okay. So let's start it. Let's create an array of CNET array equals to, so we are just splitting the array, okay. splitting the string. Now we need a stack as well, right? So let stack equals to an empty stack for now, and then we start for each of the elements in the CNET array, right? So let as of CNET array, so that would mean that each element of the CNET array we compare. So first, if stack is empty, so if stack stack is empty, that is when we push to the stack, right? So we push as, and also when are we pushing? Let's see here. So we push if we if the top of the stack is equal to the CNET, right, to the current CNET in our CNET array. So that is also when we push. So or stack dot the last element, that would be stack dot length minus 1 would be the top of the element, which is equals to stack the current CNET as, that is also when we push the CNET. All right, else what we do is, if stack has some element and it is not equals to the current CNET, that is when we pop out of the stack, right? So we pop out of the stack, and what we did here is, let's see here, so we had an R here, all right, and we found a D here. So what we would do is we exercise the power of R, so we kill this D, and then since we have now exercised its power, we added R to the end, right, appended to the end. So that is what we are going to do. Killing means like we are just doing nothing. The D is just there without, we just don't add it to our stack, right? So now we are adding to our CNET array, we just push to our CNET array the last element of the stack. So we pop out of the stack the element and push it to the CNET array, and then finally we are going to return if the stack consists of an R, then the radiant is the winner, else jar is the winner. Okay, now let's try to run our code and see if it works. Awesome, it worked. So I have actually added few test cases here. You could just try to run these test cases because these are for different scenarios. So just try to run these test cases for yourself. This test case was given to me by LeetCode because I ran into an error, so that was when it was given to me. Okay, so you could just test it for yourself. Now let's try to submit this code. Okay, awesome. Let's talk about the time complexity here. So here, since we are creating a CNET array and a stack, so our time space complexity becomes O of n. All right, and since we are also iterating over each of the CNET, the maximum length of the CNET array and the stack will not exceed the the length of the CNET. So time complexity is also O of n. Okay, so that's all about this. I also did solve this using a different approach here. If you want, you could just go through my approach here by looking at my solution. All right, so yeah, that is all about this, and I hope you liked my solution. Let me know in the comments down below, and please don't forget to like my video and subscribe to my channel. Hope you have a great day.